Part A'ers, welcome to video 3. Here we focus on writing variable expressions, okay? So we know that when we are trying to write variable expressions, we have to kind of figure out what word in English goes with what operation, all right? So let's go through and just talk about some of the words. This isn't going to be like a super long list, but we need some of them, some of them. So the very first one I would say for addition is the word sum. If you see the word sum, you know you're talking about addition. Other words that mean addition, well, we know add, more than, increased by, oh, let's see. I feel like I'm missing a bunch. I mean, that's pretty good. Hopefully you guys get the idea. Kind of going the opposite way of addition, when we talk about subtraction, we're no longer talking about the sum, but we're talking about the difference. All right, and so we know we can use a word like subtract. Another big one that we use a lot is minus. We can say less than. We can say decreased by. We can say take away. I don't know why I'm feeling better on my subtraction words than addition, but again, this is just a little list. All right. When we talk multiplication, we're talking about the product of values, okay? So product. Easiest one we say would be multiply, but another big one that we use a lot is times, right? Two other very big words that we'll see, or not very big words, they're small words, but they mean multiplication, and sometimes we forget about them, are words like each and per. All right, when you see words like each or per, that means that you're, like, you know the price of one orange, but you're buying 12 oranges, right? So if you have $1 per orange, well, you have to multiply that amount by how many ever oranges you have, okay? So these are two more words that I would probably look out for, and then a very, very specific case for multiplication that kind of goes along with times is the word twice. So I'm going to put that one off to the side because that's just a very specific situation. But we know when we see the word twice, that means 2 times. Okay? For division, this goofy word quotient. All right, quotient is when you divide two numbers, or the value when you divide two numbers. It's called the quotient. We say divide. We say sometimes split. We can say grouped. Let's see, any others that I can think of right now. Divide, split. I think that's all I got for right now. But, again, if you see something like quotient, divide, split, grouped, that means division. And then another good one just to talk about that's kind of goes along with this twice is half. All right, when we take half, that means you're dividing something by 2. All right, this means divide by 2. This means times 2. All right? Okay, so now that we have a little bit of a list here, let's see if we can go from English to math. Let's see if we can go from English to math. So a number increased by 6, and remember that we're going to use x for our number. Well, what did we say? Increased means we're adding. So I'm going to take the number, and I'm going to add 6 to it. And it is as easy as that. What happens when we have a number multiplied by 7? Well, we take our number, we multiply it by 7. The one other thing I would do on this one is I would remember that a lot of the times when we see something like this, when we multiply a number in a variable, we like to write the number out front. Something like that, 7x. Okay? The sum of 9 and a number, well, sum we said was addition, 9 and a number, well, so it's 9 plus x. And then our last one, 5 less than a number. This one's tricky. Is it this? No, It's not. It is not 5 minus x. You have to remember that if you're trying to find 5 less than a number, right, you need to have that number originally. So you need to have the number, and then 5 less of it means you take away 5 from it. Okay? So be on the lookout for that one. 5 less than a number. That's a tricky one, but I think if I remember correctly, we did pretty well on that during the school year. All right, so those are some examples of when you would have to write out an algebraic expression. And now, word problems. One of my favorite things, word problems. All right. When we have a word problem, we need to first figure out what the variable is. All right. And my hint for you guys there is find out what's unknown. Figure out what's unknown. So when we look at this and we read this problem together, Maria earned 5 more points on her test than Alyssa. If Alyssa earned P points on her test, write an expression to represent how many points Maria earned. Okay? Ooh. Well, I know that Maria's earning 5 more points. Okay, so I know that. What don't I know? What don't we know, I should say? We do not know how many points Alyssa earned. It's P. It could be 1. It could be 5. It could be 80, right? We don't know. So this P is the variable. And P is equal to, let's say, Alyssa's points. We'll say it like that. Now the next thing we need to kind of figure out is, let's see here, write an expression to represent how many points Maria earned, okay? So how many points Maria earned? Well, that depends on Alyssa's points. We know that Maria, her score depends on what Alyssa earned, okay? So now, we know what we're writing an expression for. We know what our variable is. Now we just need to figure out, is it going to be like x plus 6 or 7x, something like this? And so what you need to do is you need to go back, you need to read through, and we need to understand that because this is 5 more points, what do you think this word more means? We said it earlier. It's going to mean plus, okay? So we would finish up by saying we're going to take Alyssa's score, or Alyssa's points, and we're going to add 5. Because we know that whatever Alyssa scores, whether it's 50 or 60 or whatever, we know that, Maria is going to be 5 more. And so that would be our variable expression. Now, if we move on to the next one, let's see here. Okay, movie tickets cost $7.50 each. We buy T tickets. Ooh, I think I already know what we don't, or what's unknown. All right, let's write an expression to represent the total cost of the tickets. Okay, so the total cost of the tickets is going to do what? That has to depend on the number of tickets, right? I mean, we don't know the total cost unless we know the number of tickets. And guys, that should be a big hint that we know what our variable has to be. Our variable has to be the number of tickets. And again, I ask, does that make sense? Is that unknown? Do I know exactly how many tickets we're buying? No, it says T. Maybe it's 1, maybe it's 2, maybe it's 3. I don't know. So that is why T is going to be our variable, and it represents the number of tickets. Now the last thing, we need to write this variable expression. We need to go back. We need to read, and we need to figure out what type of operation we're using, okay? And this is where and why I wrote earlier the word each. Okay, the word each. Movie tickets cost $7.50 each. If we go back up and we look at our list, where did we see the word each? Ooh, multiplication. Okay, so I know that this is going to be times. That means that I'm going to take that value that I do know, and I have to multiply it by my variable. All right? Awesome. Almost done. Last one here. A game of bowling costs $5 for shoe rental plus $10 for each hour we bowl. If we bowl for 8 hours, write an expression for the total cost. Okay, so the total cost to bowl depends on a couple of things. Well, it depends on the shoe rental, but that doesn't change, right? The shoe rentals, no matter what, it's going to be $5. So really, the total cost only really depends on number of hours bowled. All right, the number of hours bowled. And so that should hopefully help us figure out and understand what our variable is going to be. Again, $5, we know that amount. $10, we know that amount. What don't we know? We don't know how many hours. So h is our unknown. So h is our variable. All right. Now, this is what I would call a two-step variable expression. We're already starting, no matter what, to go bowling, you have to pay $5. All right, you have to pay $5. So we know that no matter what, we're paying the 5. Now, what else is happening? Ooh, plus. Oh, I didn't use that before. Let's add it to our list now. Plus is addition. Plus is addition. So I know I'm going to be adding, and then it says $10 for each hour. Ooh, again, each. Each means multiplication. So we know that it's $5, and then for every hour we bowl, we have to pay an extra 10. Okay, so 5 plus the $10, but that $10 is multiplied by the number of games we bowl. Okay? All right, so there is a good review of writing variable expressions. Please try the next set of problems on your own and see how you do. See you in a bit.